what we're going to try to do now is have a quick summary, quick verbal summary from each of the breakout groups. We'll write up the notes and whatever was talked about in those groups separately, but we'll just have a quick verbal summary of some of the key points from those breakout groups. I've handed out some of the runner mics to a few of the folks. We'll go through each of the breakout groups, get a quick snapshot, verbal update, summary of how the breakout went and some of the key points that were discussed. As Kirsta said earlier, I'll ask each of the scribes to write up the notes that they captured, at least get them to me, and we'll try to put them all together in one update for the group and get that out to everybody. So apparently our platform children couldn't play in the same sandbox. The hardware and software people couldn't really stay at the same table. So they split into two subgroups. So why don't we start with the software guys, because I think they'd have a fit if we let the hardware guys go first. So John, why don't you give us an update?
Well, I mean, the reason is always you've got to have a scapegoat, right? I mean, if you talk together at the beginning, then you don't have that at the end, right? So it's better you separate, and then you can blame each other later. So, so what we decided. So aside from splitting up, and I think what we want to do is take these conversations online. Hopefully there'll be some interplay, so it's not just software, hardware guys that are separate. From a software point of view, we talked about the need to define the different use cases for these systems, RISC-V systems. So whether they're client or server, these kinds of things are to be defined. But clearly there are different use cases, maybe different profiles as we end up calling them. We do have an interest in describing a specification that would include a set of hardware devices that would be in a quote-unquote standard system for some of these use cases. And we do have an interest in defining some of the software interfaces. That all said, where we left it, I think, were two outcomes. Firstly, that we want to take this to an ongoing conversation on a semi-regular basis, and we'll follow up on that. And secondly, that we thought it would make sense not to boil the ocean to begin with, and to reach out to the folks working on QEMU to look at maybe a MacVert minimal set of devices and say, look, if we go and try to prescribe a whole universe of hardware, people are going to just use what's in the QEMU model anyway, so why don't we just work together, come up with a basic description of a virtual machine that doesn't have virtualization to begin with, and then build upon that.
Thanks, John. Any questions for John on that topic? Okay. So who's the hardware spokesperson in your group?
So we didn't get very far, but we had a heated discussion that led nowhere on whether we needed a bus interface or not for the RISC-V. And so the analogy was ARM has AMBA for plug and play, and that's kind of their bus API that they've chosen. In this case, there was a question whether RISC-V even needs a bus API, or whether the hardware, it's really up to the SoC implementer to do that. So that's the question that's on the table, and I think it's a broad question. And then there was a discussion on defining the address map at a minimum for example, what address do you come up out of boot, right? Is it address 0? Can we all standardize on it being address 0 forever? Or something like that. So those are the questions, but no resolution.
And one of the things that we'll certainly need to focus on and decide on as a community is, as I said earlier in my presentation, the charter and purview of the foundation is the ISA and the specifications associated with the ISA. And as we start sort of morphing into on-chip bus structures and core implementations and the IP, underlying processor IP of those implementations, how we handle that, either as recommendations or just white paper documents or whatever, that's a TBD in terms of what we want to do as a community within the foundation. But the spec and the licensing that will come through the membership agreements and the bylaws and so on are clearly focused from a charter standpoint around the ISA itself. Okay, Tim, who's your spokesperson on the debug side? Come get one of these mics.
So I guess we mostly talked about debug in the context of the presentation I gave and what people did and did not like about it. What did I write? We mostly agreed on what the basic feature set should be. We talked a tiny bit about trace and how it might be nice to be able to trace more arbitrary things than just the instructions executed. Some people wanted to see well, what does a pipeline look like over time? We talked about how in my proposal all debugging goes over the system bus, and some people, and I forget names, didn't like how that's intrusive on the system. They've been working on and have working their own debug solution, which talks directly from what in my picture would be the debug transport module to the RISC-V core without going through the system bus. The obvious benefit there is you don't interfere with the system running as much. One downside might be that you need to route more additional signals, which depending on how many cores you have is either easy or less easy. And then we spent a fair amount of time talking about my idea of having a little bit of ROM next to the RISC-V cores to help with the debug. Most people seem to feel that that was unnecessarily complicated, and it's simpler to just add a halt mode to the core so that so that you can basically halt the core and expose any register that you might want to read either as a CSR or over the system bus or through some other mechanism that does not rely on executing instructions to see them. I think that's the main points we hit. We agreed to continue discussion on a mailing list, and I think that's where we left it. Is that right?
Okay.
All right.
Thanks, Tim. Validation stuff. Nikhil, you got a mic? Good.
So I actually put up my hand for this topic because it's something I thought I didn't know anything about, and I'd like to learn about it. Next thing I knew, I was the leader of the group. To my pleasant surprise, all my colleagues seemed to be in a similar situation, so that was okay. Yeah, so I mean, I came to this from a practical problem. We tweak our design every day, maybe a couple of times a day, and every time you tweak it, you don't know whether you've broken the design. And all we do is we run it through a bunch of programs again, and if it looks good, it looks good. So it seems to be a rather fragile thing to do. So I came to find out if there's tools available for this, or the more systematic ways of doing it, etc. I think broadly speaking, amongst everybody at the table, it basically comes down to, first of all, A/B testing. You're testing a model, for example, against an implementation, or maybe even a newer version of your model against an older version of your model, but it's some kind of an A/B testing. And the things that are being tested are either some ad hoc collection of programs over the years that people have found, or through previous bug encounters, or just random instruction sequences of you said about thousands or hundreds of thousands of sequences long, and running an A/B test. That is, you run that through your thing under test, which may be your implementation, and against a model. I think the thing that's really missing is any sense of completeness of these test suites, number one. And the second thing is, in every case, it seems to be that people build these A/B test infrastructures from scratch and rebuild it and rebuild and rebuild it. So everybody around the table had a different version of it. So if there's, I don't know if there's some possibility of coming together, it'd be nice to have some kind of an abstract testing mechanism by which you can parameterize not only what A and B are, but what is the correctness criterion by which you decide whether they're diverged or not. It gets a little complicated because it's not always an exact match. I was giving some examples from RISC-V in particular. You have an instruction which says read cycle, for example. You don't expect that to be the same in your model and your implementation. So you can either give up on that, or you can tweak your correctness criterion to say, let's forgive this particular difference. So the point is that it would be good if we could have some kind of a parameterized system by which we can set up this framework and also be able to tweak it so that it can handle these kinds of situations like this.
So we developed a lot. There's this thing called, the keywords are test VMs and torture. So test VMs are the environments that what's legal for assembly code to test, including things like, is it legal to read the cycle counter? Legal to read the cycle counter. So we have this notion of abstracting tests, so they work along the maximal set of things, but that means they're constrained to use only certain features of the machine. So we spend a lot of work on that. And then we just released Torture, which does constrain random tests that builds random things that obey the constraints of a given test VM. So that's kind of part of the story. The other piece is the coverage. And I think we've been looking on the chisel land of extending chisel to help tell you the coverage that your test, like which signals have been toggled, which states have been reached, and things like that. And ultimately, we'd like to be able to feed that back into the generator to automatically get you coverage, but that's a very tricky thing.
All right.
Right. Well,
Anything
now
else?
that I've exposed my ignorance on that, I hope at the session after this, at the poster session, somebody will come and educate us all about this.
Thank you. And thanks for volunteering. Okay, I think, Peter, you're up next on the marketing outreach stuff.
Okay, so the members in the marketing team were William Lee, Jothy Rosenberg, Neil Hand, Martin Schoberl, Mikhail Gielda, Angelica Romero, myself, Stephen Chan, and Ted Spears. So we came up with a number of things for this, and one of the areas that we thought would be good to mention is specifically the value proposition and the unfair advantage that RISC-V has over other processors in the space. So the open or common base was number one in terms of the advantages. The idea of being able to leverage some of the benchmark data of the lower power and area slides that have been presented at past RISC-V workshops would be great to have as well. The other main advantage that people thought was an unfair one was the ability of the RISC-V to operate in heterogeneous computing environments. The other broad brush stroke was in the unique electronic design process using either BlueSpec or Codicip or Chisel types of things to implement designs in FPGAs or full custom. The common software ecosystem, the ability to put in closed security extensions and really leverage the ISA open source, unrestricted or no royalty for commercial and also for educational environments. Using a modern operating system was another one. In terms of the marketing areas, we thought we should be present at a number of conferences and shows, from things like DAC, Hot Chips, CES, ISSCC, some of the low power conferences, some of the comms conferences, supercomputing. We basically would like to try and build the press for the marketing process with strategic partners so that announcements can be made in sequence or at the same time. The other area that people thought was a significant advantage was the compliant, expansive microarchitecture that the ISA provides. From education, one of the other areas was we should focus on the embedded conferences. There's one coming up in Germany, and also the ability to do hangouts if we cannot be at actual conferences, so that the RISC-V community at least can talk to each other on something like a Google Hangout. For education, one of the main areas was that we'd like to look or approach number of authors to add a chapter on RISC-V in the computer architecture books, or even develop a new RISC-V book. Course notes, outlines, course material, development kits. Have something called a RISC-V UP, university program. Workshop and planning for the next one, looking at a client company to build an actual board for the RISC-V UP or university program. Let's see, what else did we have? Anybody else want to contribute? Anything I missed?
So I think one thing we're talking about is, for many of the companies we work with, the advantage is there are a lot of companies who have our own promotional resources, and we want to have a common set of how we talk about RISC-V, what is its vision, what is its very specific value statement. So as we go out and talk, we use the same language. It went a step further. We also talked about combining those marketing efforts. So when we talked about shows, one example that came up is there's a number of the member companies are going to be at Embedded World. So having a passport type thing at Embedded World where people go around to each of the vendors, we make an effort to have a very specific messaging, promotions, common things. So RISC-V looks bigger, so more people are aware of it, so you get that promotion. So a lot of very practical things about how you can leverage the fact that you've got both commercial as well as open source. And the open source implementations, the academic can leverage the resources of the commercial guys. And then we also talked about we did touch on the workshop on the student contest where we're talking about leveraging, again, talking about common resources, something like Microsemi defining an FPGA platform, defining a common set of inputs for a student contest and maybe even a wider contest so that you actually get people productive very quickly. But the whole idea was, get all the member companies together on the same page, pushing in the same direction and leveraging the resources.
Sounds good.
And probably the first place you see it is Embedded World.
Sagar, are you up?
Yeah, so I'm Sagar. Actually, the last two letters of my name are flipped up there. But anyway, so just to give some background on QEMU. So once upon a time, around the time of the first workshop, QEMU kind of had full RISC-V support. It could boot Linux, which is kind of my benchmark of it working. So just to clarify my status update, so it's kind of 80% of the way updated. So I think it should be done in a couple of weeks. So by done, I mean boot Linux, run stuff on top of it. And one of the questions posed was, is there kind of anything other people can do to help there? My answer was, at this point, it's probably easier just to have one person finish it than to have someone else learn about kind of the internals of QEMU. That said, if someone else here is an expert on the internals of QEMU, that would be a big help. But what can be contributed? So one of the things is that when we talk about QEMU right now, we're talking about the system mode of QEMU, which kind of acts like a real piece of hardware. QEMU also has this user mode that lets you kind of directly run user programs, which is something that's a to-do. But that's something that's really more like just stripping out some code from the system mode of QEMU. And we also have the proxy kernel, which can do very similar things just on top of QEMU's system mode. Another thing that can be contributed, which is sort of independent of getting QEMU up, is to modify the TCG backend so that we can produce RISC-V code in the backend. So the way QEMU works essentially is it takes kind of the instructions of the thing you're trying to simulate. It converts those to an internal representation called TCG, and then TCG gets translated into the host's machine code, so it can JIT and run that. So right now, when we talk about porting QEMU, we're talking about getting RISC-V machine code and converting it to TCG, so that the existing TCG backends can produce x86 code and run it on kind of the real machines we have right now. So in the future, it would be useful once we have real RISC-V hardware to be able to take other things, other ISAs that get translated to the kind of TCG language and have them run on top of RISC-V machines. So that's something that can be done independently. There's kind of no real good way to run it right now except by running QEMU inside QEMU. Then there was a question about upstreaming. So QEMU is GPL'd, so there's a lot of the same issues that came up with upstreaming the other stuff. But the contributor list is much smaller, so hopefully that should take a lot less time. And there's another general question about how to bring up new simulators, and my answer was was sort of just to have your new simulator produce output that looks very similar to the Spike debug output and to diff it.
All right, thank you. So who's doing the memory model update?
I'm doing it. This is Paolo Faraboschi from Hewlett Packard Enterprise, and Krista was the lead. I was volunteered to be the scribe. So we talked about 4 areas primarily. One is sort of framing the problem of memory models and ordering. Second one was the ordering primitives. Then we talked about errors, and then we talked about formal verification. So I'm going to try to spend a couple of minutes on each of them. On the general problem, I mean, the consensus was that it was kind of hard to separate the memory models from the ISI itself. They're all about ordering and visibility, and you know, the overall principle of RISC-V is a valid one, that, you know, everything is relaxed and that fences are what imposes ordering and no cache management. But they're, you know, a big issue in trying to reconcile the needs of the hardware community, the software community, and the formal verification community that historically haven't really understood each other very well. The problems that we're trying to solve are also complicated by the fact that the memory systems are getting more and more complicated. Right now and in the future, we're seeing system caches, we're seeing the appearance of non-volatile memory, we're seeing multi-level hierarchies of memories, where, you know, the individual points of the memory hierarchy might require separate language bindings to try to express, you know, visibility and ordering points in different places in the memory hierarchy. So this is sort of the framework of the problem we were trying to address, and clearly would like to do that in a way that decouples the mechanism from the implementation itself. In terms of ordering primitives, the fences are sort of what RISC-V uses as mechanisms. There was a discussion of whether we should try to implement finer grained fences that identify either objects or regions or ranges, so that, you know, you can more finely tune, you know, the acknowledgement patterns between, you know, memory operations. There was some reference to previous architecture like CEL that had, like, you know, bit mask to explicitly specify ranges. Or, you know, use completely different mechanism like a DMA operation that might, you know, enforce with a copy semantics persistence, for example, to a persistent memory region. We also talked about trying to do relaxed fences along the lines of open power, and these are all, you know, prime subjects for, you know, follow-up working groups. We spent quite a bit of time talking about errors. Clearly, part of the memory specification and the memory model is how you deal with memory errors. This is somewhat related to the platform standardization, because not all profiles will require precise handling of errors. There's a consensus that clearly it'd be nice to leverage a lot of work that already happened in x86 and ARM space in terms of machine check architecture, delivery of precise errors, you know, poisoning, and so on and so forth. Probably requires a separate working group, not something we could solve today, and definitely needs something where, you know, we need to, you know, sync up with the platform architecture folks. We also talked a little bit about formal verification at the end, the fact that there are various types of loads and stores that needs to be reconciled with respect to the various type of fences. There was a feeling that maybe the specs aren't fully specified. There may be some holes here and there in the various dependencies. And also there was some comments about, you know, how do we handle things like legacy code, where people may already implement, you know, fences using patterns like multiple stores to a device address that, you know, are not currently supported in RISC-V, and do we outlaw them, or do we try to capture them in some other form of formal verification? So rather than giving answers, I think this opens up a lot of interesting areas for future discussions. This is definitely something that, you know, I think the feeling was that there's a lot of work to be done in this space.
Juicy topic. Okay, last update from the security group.
So there were about 12 to 15 people, and since security means a lot of things to a lot of people, we started by trying to identify what are the security-related topics. We came up with 9 different topics, from secure boot, memory protection, CFI, tagging, crypto, side channel analysis, anti-tamper, secure enclaves, TPM, and hardware fabrication security. So upon a lot of discussions, we agreed that there's a need for at least 3 subcommittees. One that will deal with the secure policy enforcement or tagging, one to deal with crypto extensions, one to deal with the platform-related issues. There is some overlap between these tools. Side channel, for instance, can be can fit in the crypto part or the platform part. And lastly, there is a need to discuss some secure debugging issues that I think we need someone from the debugging working group, I should say. So that's a brief summary of the topics that we have discussed. And obviously, we haven't come up with any solution.
Great. No, that's, it sounds like all of the discussions were very healthy. So thanks to the group leaders and scribes.